Hello, everyone. Welcome to the ASCME Journal of Computing Information Science Engineering JCISE monthly spotlight talk. Today is my pleasure. My name is Yang Wen, of Editor-in-Chief, current Editor-in-Chief of JCISE. It's my pleasure to introduce our speaker today, Professor Chris McComb. Chris is an associate professor of mechanical engineering at Carnegie Mellon University. His research expertise areas include machine learning in design, AI, as well as human societal systems. Chris recently is the director of the recent initiative at Carnegie Mellon of Human AI Design initiative. Today, Chris is going to give a presentation of his paper, co-author with Glenn, Nicholas Maisel, and Tim Simpson. The title of the paper is Design for Artificial Intelligence. Please take away, Chris.
All right, Jan, thank you so much for the gracious introduction, and thank you for the opportunity to share this work today. And thank you everyone for showing up. So today I'm pleased to present our work on design for artificial intelligence, or DeFi, and I cannot give Glenn Williams enough credit for the work that he did in this project. Glenn, as is the way with grad students, did the heavy lifting. He coined the term design for artificial intelligence, and it was just really a pleasure to work for Glenn. He's currently with Rebuild Manufacturing in Boston. And of course, Nick Meisel and Timothy Simpson they've been around at DTM and DAC for a while. We know them, and it was great to collaborate with them as well. So this idea of design for artificial intelligence is maybe a little atypical compared to the other DFXs because it's a little bit broader. And we'll see what that means as we discuss the idea today. So this, like much of my work, comes out of the idea that AI is changing the way that we do engineering and the way that we do design. So we know that AI adoption is really common in industry and increasingly common in areas that are engineering relevant or engineering adjacent. So we see a lot of AI adoption in product development, service development, that's used for both design and also implementing AI enhanced features. It's used in manufacturing, it's used in service operations, supply chain management, and these figures are also 2 years old, right? So it is even more common today. And we're starting to see, products that are coming out that take advantage of AI to achieve superior performance, right? So we're seeing a lot of high-end products that take advantage of AI. And many of us here now do some sort of research or do some work at this intersection, right? This combination of engineering design and manufacturing and artificial intelligence. And it's a really exciting area to work in, right? This combination is it's just fascinating. But what makes it maybe a little frustrating to study sometimes is that each of these areas is rapidly evolving. Right? It's dynamic. It's impacted by Industry 4.0, deep learning, cloud computing, right? Lots of emerging trends impinge on each of these different areas. So they're changing, they're dynamic. The relationship between the disciplines is changing as well. And taking advantage of quickly moving technology, right? New automation technology, new AI or ML technology is difficult. Right? It's risky. And that's because there are a variety of fairly well-known and troublingly diverse failure cases, right? So on the left, we have Tay, which was a Microsoft chatbot from 2016 that was on Twitter for like 2 days before becoming extremely racist. We have the Boeing 737 MAX issues, right? Canonical case of failure in automation. And then there's lots of stuff, lots of research being done in automated driving systems to account for the issues that we see there. So automation has the potential to cause issues. It's risky. So we need to navigate automation, navigate AI and ML for engineering design carefully. But it's hard, right? Because we have three very different disciplines that are all connected, that are all rapidly evolving, and that have extremely diverse failure cases, right? So we thought that this is a context that is ripe for some degree of standardization. So we introduced the DeFi framework as an agenda and a framework for safely navigating the design, manufacturing, AI nexus, this combination of disciplines. We want to make sure that people can take advantage of AI and machine learning for design and manufacturing, but do it in a way that is safer and less risky. So in the talk today, I'll introduce our DeFi objectives and our focuses in that work. We'll also talk about the 6 initial DeFi principles. And then towards the end, we'll talk about the DeFi doers, the personas that we think we're going to need to make DeFi happen. So starting off, what the heck is DeFi? I've used that word like 20 times at this point. So it's time I offered a definition. DeFi is a set of focuses, principles, and personas, the 3 things we'll talk about today, that aim to improve the effectiveness, adoption, and level of innovation of AI for engineering design and for manufacturing. So that's our sort of overarching term. Like I mentioned earlier, this is maybe a little atypical for a DFX or a design for X framework, because we think of this at a slightly higher level as almost more of an agenda for driving this DFX forward. And the 3 bubbles shown here are 3 areas or 3 focus areas where we think DeFi can have the most positive impact. And the first focus area is on raising AI literacy by driving collaboration. AI literacy in this case, I think can be taken to mean the terminology that we use to talk about AI. And there are some gaps, right? So if you compare the terminology and the language used by academia versus industry, right? We use very different terms to discuss AI. And in some cases, I'd say that maybe academia is a little more AI literate when it comes to things like, opportunities in AI, whereas industry is probably more literate in challenges when it comes to AI, right? So we bring different pieces of the puzzle to the table. But then also between disciplines, right? If we talk about AI within a biology context versus in an engineering context, the issues and the concerns are drastically different, right? So talking across these boundaries and driving collaboration is a first step towards standardizing some of this language, making sure we can talk to each other, and forming a growing AI design community. Once we start to form that community, we can focus on the next 2 focus areas. So focus area 2 is on redesigning our typical engineering systems to meet AI growth needs. So one of my big buckets of research is on human AI collaboration and the types of engineering systems that we have today, right? The CAD programs and the documentation approaches and stuff like that is woefully underprepared to support AI or to ingest large amounts of data. So we need to be thinking about how to redesign those systems in order to keep pace with AI. And then the third focus that we have for DeFi is to use DeFi to enhance the AI development process for engineering and manufacturing. So you might be familiar with some of these logos. On the left side of the screen, we have tools and software packages, right? PyTorch, TensorFlow. But then as we get to the right side of the screen, there are other items that are less tool focused, but equally important for the AI development process, right? Where you get your data from and how you clean and process your data is vital. How you share results and share insights and share and learn about algorithms is really important, right? Preprint servers or standard publications. But then also at a human level, the team processes and the team composition in which AI development is done is equally essential. So when it comes to enhancing the overall AI development process, that's going to benefit from a really cohesive look. So our 3 focus areas for DeFi as we advance this principle is to raise AI literacy, redesign existing engineering systems, and enhance the overall AI development process. Next question, how the heck are we going to do that? So we spent some time thinking through an initial set of DeFi principles, and we'll talk through those next. These principles focus a lot on data and maybe a little less on AI. And I think that's probably because that's where our focus needs to be right now. There's a figure that I love that I should have put in the presentation that's about the AI hierarchy of needs, right? The rungs in the ladder to achieve a full implementation of AI. And it starts off with data dashboarding and analysis, right? Simple steps, but equally important as the ultimate goal. So we articulate 6 of these initial core DeFi principles, and we'll step through each of these separately. They are digitization, data valuation, metadata quality, machine readability, data linkage, and evolution. So our first principle, digitization, is really the idea that in order to become an organization or a lab or a person who embraces DeFi, you should embrace the idea of capturing and storing every scrap of data possible as a standard practice, right? We talk a lot about how additive manufacturing has a deeply rooted digital thread that produces lots of data, but increasingly other manufacturing processes and other design processes also put off large amounts of data, and we should be capturing that. So that's the first principle, digitization. Let's make sure that we're capturing the meaningful things. Second, data valuation. So now that we have our hands on data, right? Now that we've captured our engineering and manufacturing data and we're planning great things with it, we need to figure out what the value of this data actually is, right? So the second principle is to assess the current and potential future value of engineering data sets. And the current versus potential future value can be drastically different. So you can imagine a small mom and pop company that starts collecting some data on machines, and they don't have anybody who can really work with that data yet. So the current value of their data set is probably pretty small, but the potential future value is huge, right? So for DeFi to be effective, we need to start thinking about principles and techniques that we can provide to people to help assess the value of their data. The third case, or the third principle for DeFi is metadata quality. So the principle here is to develop and maintain metadata that describes both designs and the repositories that they're part of. So here, I always come back to the issues with STLs, right? So STLs maintain geometric data, but they don't maintain any metadata, right? And I think this is, in some sense, the one difference between the type of AI research that we're interested in engineering and the type of AI research in computer science, because these metadata qualities are really important for us, right? Things like material, things like intended manufacturing process, surface finishes, all of that, right, is vital to defining the functionality of a solution. So we need geometry data, but we also need metadata as well. And developing, maintaining, curating, and auditing that is important. Our next principle is machine readability. So not only do we want to store data, but we want to store it so that it can be operated on extremely easily and without human intervention. So this builds on the other ones, but with a specific bent towards making this data accessible to machine elements. Our fifth principle is linkage integrity. So another unique aspect of engineering is that we often extract different types of data for the same artifact at different times. So if we think about a scan to print process, right? We are doing a 3D scan. We're generating a point cloud of an artifact. And then we go through some transformations, and towards the end, we're generating G code that describes the shape in a very different way. So we need to create linkages between these diverse data streams, and we need to make sure that they're maintained and auditable, because that's the only way that we can start to really make insights across the entire design process. And then finally, the sixth initial principle for DeFi is evolution. DeFi principles must evolve with advances in engineering design, in manufacturing, and in AI and machine learning itself. So I think I actually started off this talk talking about how engineering design and manufacturing and AI are dynamic, right? They're changing, they're evolving. And I think it would be hubris to think that DeFi could be a static entity. I think that because of the focus on AI, because of the focus on rapidly evolving fields, DeFi should have processes built in to evolve as well. So this is not a static framework. This should evolve and it must evolve. So these principles are not just relevant or germane to the design of final products, but they're also relevant to just about any area within corporate life. So we can think about applying these DeFi principles to the things that we design. We can also use these DeFi principles to inform the infrastructure that we create to store design repositories. DeFi principles might inform broader organizational practices or the creation of infrastructure to support AI development. So these principles are far-reaching and should be applied that way. The last item in this section is a short example that I think draws out an important difference and an important challenge with implementing these DeFi principles. So think about a startup that's inventing small electric aircraft for the shipping industry, right? So it's a startup, they don't have a ton of money, right? They're on a short budget, they don't have a ton of staff, and they have a choice. They can either pursue a traditional engineering approach or they can embrace DeFi. And today, if they were to make this choice, these are what we think the possible outcomes might be. So if they embrace DeFi, there's likely to be a substantial upfront cost. Curating data, recording and generating models, training agents takes time and it takes effort. So there is a significant upfront cost, but it has a potential to increase long-term competitiveness, right? Building infrastructure early on pays dividends. But also, data curation could improve other business processes. So there might be the potential for DeFi to have systemic benefits. If this company instead decided to take a traditional approach, they probably have smaller upfront costs, right? Upfront costs associated with engineering, design, manufacturing, business development, the typicals, right? But in the long term, I think their competitiveness would be comparatively lower, right? Because they're not accruing organizational data, organizational knowledge, right? But, if I was running a startup and trying to make a pitch to investors that I wanted to, hire 3 people to work on things that aren't going to pay off for a couple of years, which is often the development cycle for new AI models, that's a hard pitch to make. So balancing short-term and long-term objectives is going to be a challenge for DeFi. So that's the high-level overview of these DeFi principles and of the potential value of these principles. But the last question, and probably the most important one, is who are going to be the DeFi doers, right? Who are going to be the people who put these principles into practice and actually make change and make the world a better place with AI? So we gave that some thought too. And we thought through 3 different personas, or you can think about them like job descriptions almost. And we think that these 3 and the way that they work together are really important for advancing DeFi in practice and in industry. So we thought about the connections between engineering designers, design repository curators, and AI developers, specifically within an engineering and manufacturing context. So our design repository curators, they design the core data infrastructure, they monitor AI performance, and they track the return on investment of the overall system. So this person owns the data and owns the infrastructure that the data sits on. However, they're also, they manage interactions with other stakeholders and with these other personas. But the most important role I think that this person would fill in an organization is to track and communicate the investment and the return on investment for AI ML efforts. And in order for AI and ML initiatives to survive, that ROI needs to be very clearly communicated. I'm doing a project right now in the construction industry, and that's one of the biggest barriers for effective integration of AI and machine learning. So design repository curators are where it starts, right? They get the data, they make the data accessible. Then we need design AI developers. So design AI developers consume that data, they create AI, and they're also connected to a broader design AI community. And this is an important part of our vision for DeFi. We see these design AI developers, probably as, advanced degree graduates. So they are able to bridge between the academic world and the industrial world. So they can create the AI constructs that are cutting edge. They consume the engineering data and have some engineering knowledge to make sense of it, but also they contribute to this broader community. And then finally, we have our engineering designers. This is an older role, right? Engineering designers have been around for a long time, but in a world that embraces DeFi, the job of an engineering designer is going to look a little bit different. So engineering designers will increasingly use AI software that's produced by design AI developers using data that's curated by design repository curators. But engineering designers also need to own the engineering content. So they need to be able to define and share engineering problems with the other personas. They also need to be able and ready to contribute data. And this is an important linkage because engineering designers need to be prepared and given tools and capabilities to contribute clean and meaningful data. So it's important not only to establish these three roles or establish these three personas, but to make sure that they're connected and supported. So there are important connections and important flows between each one of these, but each one of them also benefits from and contributes back to institutional infrastructure. So there is also this infrastructural layer that supports the work of these personas. So that sums up the majority of my presentation for today. So we introduced DeFi, or Design for Artificial Intelligence, as a new DFX framework, but more importantly, as an agenda for the future of how we do AI-enabled design and manufacturing. So in wrapping up here, if I could offer a call to action or a call to action for folks, I would say that the people who are going to become the DeFi doers are already in your organizations. They're already in your labs. So my challenge, my call to action for everyone listening to this is to find the emerging DeFi doers in your own organizations and support them and connect them. They'll do amazing things for you. So with that, thank you to the audience. Thank you to NSF and NVIDIA for supporting our work. And finally, thank you to ASME and JCISE for inviting me to present this work. Thank you very much.